Okay, so we are in the discussion about the electrophilic substitution reaction. So here are the workouts based on the electrophilic substitution reaction. So we will start with the workouts, then we go for the final craft alkylation, final craft acylation, okay, and some other important electrophilic substitution reactions. Okay, so when it is Gutterman's reaction of formylation. Okay, so this is aldehyde synthesis, Gutterman aldehyde synthesis, where a formyl group is going to add. Okay, so when it is HCl and HCl, iminium intermediate is going to form. So that will be going to result into the formation of CH2 group addition product. Okay, so there may be the two possibilities of ortho and para. Okay, so among ortho and para, ortho will be having hydrogen bonding, so this will be the major. Okay, this will be the major. So if at all both are formed, okay, so ortho and para are formed. So this is with hydrogen bond, ortho is with a hydrogen bond, para is without hydrogen bond. Okay, so whenever hydrogen bond is there, that will be isolated. Okay, means individual molecules will be there. Whenever hydrogen bond is not there, it's going to form hydrogen bond with the other molecules. Okay, so that it can form a block of the molecules which are not isolated, okay, which are not individual. So the boiling point or the temperature required to volatile, okay, which required to vaporize these unhydrogen bonding having molecule is difficult. Okay, so boiling point is more, volatility is less for para product, and boiling point is low. Okay, so they are easily boiling, easily volatile. Okay, because of the internal hydrogen bonding. So when these two isomers are formed, they can be separable by distillation. Okay, distillation is the process where we are heating the mixture of the compounds and condensing or collecting the individual molecules in its vaporized form. Okay, so vapors are collected so that one specific molecule is going to collect at one specific temperature. Okay, so they are separable by the temperature. Okay, among these two, internal hydrogen bonding having molecule, that is ortho will be low boiling and para will be high boiling. Okay, so major product is ortho. Okay, so if this is there, the electrophile addition on the pyridine ring. Okay, electrophile addition on the pyridine ring always at the third position. Okay, if it is pyrrole ring, if it is 6-member, third position. If it is 5-member, it will be second position. Okay, so what could be the electrophile here? It is iminium electrophile. After the hydrolysis, it's going to give the CH4 group. Okay, metaformyl pyridine. Okay, so next 3-formyl pyridine. Okay, so next, if it is H2SO4, there will be two possibilities. Okay, so among those two, at low temperature, alpha will be the major, alpha substitution, this is alpha and this is beta. At low temperature, alpha substitution will be the major, and at high temperature, beta substitution will be the major. So here the final product will be beta sulfonic acid. Okay, beta sulfonic acid. Okay, beta naphthyl sulfonic acid. Okay, okay. So next, if it is pyrrole, if it is 5-membered, so this is Gutterman coach formylation. So formyl group is going to add here. Okay. So car carbonyl electrophile is going to form. Okay, formyl electrophile. So if this is the case, it's going to attach at 2nd position. So major product will be 2-formyl pyrrole. Okay, 2-formyl. So this is the major product. Okay, if this is there, it is determines aldehyde synthesis. Here, iminium ion is going to form. So the product is one and the same in both. Okay, but reagent what we use is different. So this is also going to give formylation. Okay. So if this is the case, okay, so whenever HCN is used, it becomes HC double bond. Okay. So if I write in detail, so this is going to break and is going to convert into the C double bond O. Okay. And H is same. If the same is attached with the methyl, it's going to give the addition of acetyl group. Okay. So the resulting product will be 2-acetyl. So 2-acetyl pyrrole. Okay. So these are the products. Okay. So hope you done. Okay. If any smaller mistakes, try to correct them. Okay. So but the thing is you need to apply. Okay. So how I applied here. So when it is HCl, it's going to give pharma group. When it is CH3CN, it's going to give acetyl group. Okay. So whatever may be the nitrile. Okay. So based on that, the aldehyde group is going to, or carbonyl group is going to attach here. Okay. So that's all about the workouts. So next, in today's class, we are going to deal with chloromethylation. Okay. So in chloromethylation, what we are going to do is chloromethyl means CH3Cl chloromethyl. Okay. So when it is going to attach to something, it is what CH2Cl. Okay. So for this addition, okay, for this addition, the reagent is CO and sorry CH2O, that is formaldehyde, formaldehyde along with the Cl. Okay, or you can also take HCl also. Okay, formaldehyde along with the HCl or Cl. Okay, so this is the reagent system. Okay, so once a benzene system is treated with formaldehyde in presence of the HCl, is going to give chloromethyl substituted benzene. Okay. So how it is going to happen is, so when it is a formaldehyde treated with a HCl, okay. So this is Cl minus and this is H plus. Okay. It is going to obstruct the H plus. Okay. So resulting will be and H. Okay. So now this bond is going to move towards this. Okay. So it's going to become OH here and H here. This will be the positive charge. Okay. So once the benzene system, okay, is available and this electrophile is available, is going to attack. Okay. And resulting into the CH2OH. Okay. CH2 and OH. Okay. So this is a positive charge. Okay. And the rest all will be the same sigma complex formation and electrophile elimination and everything is going to form the same. Okay. So resulting will be CH2OH. Okay. But the thing is, in this reagent system, H plus is utilized, Cl minus will be available, which will easily undergo nucleophilic substitution reaction. Okay. So OH is just get replaced with the chlorine. So resulting CH2Cl. Okay, CH2Cl. So final outcome is fluoromethylated benzene. Okay, benzene to the fluoromethylated benzene. So that's why it is called fluoromethylation. Okay. So here the electrophile is CH2 plus. Okay, CH2OH plus. Okay. So this is called hydroxy methyl carbocation. Okay, hydroxymethyl carbocation. So that is what the electrophile or the intermediate. Okay, so here are the examples. Try to work out this. An naphthalene is treated with formaldehyde in presence of the HCl. Okay, so what could be the product? Okay, so if you need more examples, you can take any other substituted paramethyl benzene or sorry, toluene. Okay, so bromobenzene. You can take anything and you can write the products. Okay, so this is what chloromethylation. And the next reaction is Friedel-Crafts reactions. So Friedel-Crafts alkylation. So what is meant by alkylation? Addition of alkyl group. Okay, addition of alkyl group. So if I use benzene, I am going to get alkyl benzene, isn't it? So during the alkylation, alkyl group is going to add. So for that case, the reagent will be alkyl halide with the presence of Lewis acid. Okay, alkyl halide with the presence of Lewis acid. Okay, so with the Lewis acid, what will be going to happen? So this nucleophile is going to attack on the electrophiles. Okay, Lewis acids are electrophile, so it's going to become R plus and AlCl4 minus. Okay, this bond will move towards this. So when electrophile is available, it is going to attack to form alkylated benzene carbocation, and which will be stabilized through sigma complex followed by the H plus removal or electrophile removal, resulting will be alkyl benzene. Okay, so the Friedel-Crafts alkylation is the reagent system will be Lewis acid along with the alkyl halide. Okay, so electrophile generation will be going to happen in presence of Lewis acid followed by the attaching of the benzene ring and resulting into the alkylated benzene by the elimination of hydrogen electrophile. Okay, so same scenario with the electrophilic substitution reactions. So it will follow everything. So you should be, I think you should get perfection about the mechanism so far, because you have seen 4 to 5 electrophilic substitution reactions and their mechanism. Okay, so if not perfect, try to be perfect with the mechanism. Until unless you are perfect at the mechanism, it will not be able to write the complete products. Okay, so exact product writing is depends on the mechanism. Okay, so here are the workouts. So if I use propyl chloride, what could be the product? And here I have taken general alkyl halide. So if I take methyl chloride, what could be the product? And if I take 3 times of methyl chloride, so these are all in presence of the Lewis acid. You can take any Lewis acid. So most preferably AlCl. Okay. So as per the reaction, it is same. This is very easy. So methylation is going to happen. Okay, when it is methyl chloride is used. Okay, because it's going to leave, it's going to give the carbon cation. Okay. So if I use 3 times, it's going to repeat for 3 times. First it will be methylated once. Okay, so uh, let me say uh, when it is 3 moles it will be 3 times available, so it's going to give triple addition. Okay, so mescaline is going to form simultaneously mescaline. So 135 trimethyl benzene is called mescaline. Okay, so mescaline is going to form when it is 3 moles of methyl chloride or methyl halide in the presence of Lewis acid is treated. Okay, so when this is the case, it is also going to generate the carbocation. Okay, so this is, so this will be the carbocation. Okay, but the thing is it going to be more stable? Not at all. Okay, because this is a primary carbocation, it will not be stable. So 1,2 hydrogen shift is going to happen. So secondary carbocation will be more stable. Okay, so resulting product will be attachment to the secondary carbon instead of primary carbon. So product will be isopropyl benzene. Okay, so isopropyl benzene, this is called cumene. Okay, cumene. So whenever you are treating with the propyl chloride, okay, so what I treat, so I had treated with the propyl chloride. So this was my reagent. Okay, so propyl chloride, which is N propyl chloride. So when I use N propyl chloride, it is given cumene. Okay, so let's see another example. When I use isopropyl chloride, okay, so this is also going to break and carbocation will generate, and secondary position or secondary carbocation will be more stable. Okay, so it is going to give the secondary attached product. So again this thing. Okay, so whatever may be the reagent, it will always go through the most stable carbocation. Okay, so remember this. Okay, and make a note of this, always through most stable carbocation. Okay, always through most stable carbocation. Okay, so whatever may be the reagents or whatever may be the alkyl halide. Okay, so you need to see the most stable carbocation that can be generated from the alkyl halide. Okay, so hope you understand. Now here I am going to give some more examples which you need to work out. Okay, so these are very very important workouts, so I expect everyone to be done. Okay, because repeatedly asked. So benzene with isobutyl chloride in presence of the AlCl2. Okay, and benzene with sorry, this is N-butyl, this is isopentyl chloride, and what could be the product? So this is tertiary butyl chloride. This is allyl chloride. Okay, try to write the names also of their of the alkyl halides. Okay, this is allyl chloride. Next, so cyclopentenyl bromide. gel bond. So it has a vast number of examples, so where you can find different molecule synthesis. So when 2 moles and 2 dihaloalkane is present, what could be the product? So this is not requiring the alkyl halide, because when it is in the presence of Lewis acid, it itself going to form the carbocation at this carbon. Okay, so it's going to form the carbocation. Okay, so let's make the vinyl carbocation. Okay, so when it is attacking, okay, in presence of the H plus. Okay, so let's say H plus is attacked here. So it's going to form carbocation. That you need to substitute and the benzene. Okay. Next, slide in the presence of H plus, or you can also take H2S before. So all are electrophile formation reactions. Okay. So acids generally releases H plus, which will result the molecules into the carbocations. So this is also DF2. That could be the product. So this is isopropanol. When it is treated with the H plus, it is going to attack, so resulting again into the carbocation. Okay, so all are Friedel-Crafts types reactions only. So here we are going to see different electrophile formation reactions or reagent systems also. Okay, so try to work out all this. Okay, so these all are very important. So here I try to share also. Okay, so next thing. So when it is spiral system, okay, and treated with the electrophile generating, okay, alkyl halide with the DF2, okay, so Lewis acid, so it's going to attack, so it's going to become carbocation, and in pyrrole system, second position is going to add with the electrophile, so it is that. Okay, so 2-methyl pyrrole. Okay, 2-methyl pyrrole. Next example. So if I take this compound and treat with the AlCl2, okay, so it is what internal Friedel-Crafts reaction. Okay, internal Friedel-Crafts reaction. So what I mean internal is, here in this molecule itself acts as a electrophile. Okay, So this is the electrophile. So by the reacting with the Lewis acid, and it can act as a benzene system. Okay. So reagent is present in it, and starting material is also present in it. Okay. So alkylation is going to happen within the system. So resulting what after the elimination is going to become carbocation here, and benzene can. So if I write in detail, so let's say this is the exact way. So once the chlorine is eliminated with the Lewis acid presence, so it's going to attack here. Okay. So resulting in what? This is one carbon, second, and third, fourth, five. Okay. One, two, three, four, five. Okay. So five-member ring is going to generate. Okay. So this is what five-member ring. Okay. So this carbon and this carbon are joining. So this is attaching carbon which is having methyl there. Okay. And this last bond means this is having positive charge. And these are the double bonds. Okay. So when it is hydrogen is there, it's going to lose H plus. So resulting again into the okay. So this is what internal Friedel curve resulting into the bicyclic systems. Okay, bicyclic system. So now try to work out. You can use any acid. H plus means H2SO4 for HCl. Okay, dilute now. Okay. So these are the workouts that you need to follow. Okay. So far it is fine. All are Friedel calculation reactions. Okay. So if any exceptions are there, okay, if any not suitable conditions, not suitable reaction types are there, okay. So there are of course exception for this reaction, okay. So whenever we use vinyl chloride or vinyl halides and aryl halides, okay, vinyl halides and aryl halides, if they are in presence of Lewis acid, they will not give carbocation. Okay, they cannot give carbocation. What could be the reason is if it is vinyl chloride or if it is aryl chloride, aryl halides, they are in the conjugation. Okay, they are in the conjugation with the ring. Okay, so it will be difficult to break this carbon halogen bond or carbon chlorine bond. Okay, so because it is almost a double bond in nature. Okay, double bond nature will be there, so it will not break, so that it will not release the carbocation. Okay, so when it is not able to release the carbocation, when I try to treat benzene with the chlorobenzene in presence of AlCl3. Okay, so this is of double bond type. Okay, so it is not going to break and it's not going to release the electrophile, so reaction will not move. Okay, so whenever it is vinyl chloride or aryl chloride, so reaction will not move. Okay, so that is the first exception. Okay, so in the second exception, whenever we have benzene with strong withdrawing groups, benzene with strong withdrawing groups. So what is going to happen? Here electrophile is not formed, but whenever like nitrobenzene is there, and if I take methyl chloride in presence of AlCl3, it's going to form the electrophile, but this needs the electron density on the benzene, which cannot be hold. Okay, which is not sufficient when it is strong withdrawing groups are there. So then also reaction will not going to happen. Okay, reaction will not going to happen. So such kind of groups, nitro, okay, and cyano, okay, nitro, cyano, okay. So these are the two groups that are going to give the weak attacking of the onto the electrophile. Okay, so withdrawing nature of the groups that are present on the benzene will decrease the attacking ability of the benzene, so that electrophilic substitution will be very weak or not going to happen efficiently. Okay, so one more exception, this is number 2, and the number 3 is when aniline and pyridine, aniline and pyridine are there, they are not going to give the alkylation. Okay, so here the reason is, you can estimate, okay, you can expect, because these two are common of what, these two are Lewis bases. Okay, and this is what Lewis acid. Whenever you are treating with the Lewis bases, so now the Lewis acid will be going to attack on the Lewis base. Okay, our Lewis acid will be attacked by the Lewis base, so it is going to form Lewis acid base complex. Okay, lab complex, Lewis acid base complex. So what is going to result? Resulting into what? The further electrophile generation will be difficult. Okay, so when all the Lewis acid is going to form into the complex, Lewis acid will not be going to react with the alkyl ion, so electrophile generation will not be going to happen. So it is going to stop the reaction when it is Lewis bases are present in the reaction. Okay, so these are the 3 exceptions for the electrophilic substitution reaction. Okay, so the first exception of the Friedel-Crafts alkylation is, it is not possible with the vinyl halides and aryl halides. Okay, and in the second, whenever strong withdrawing groups like nitro and cyano groups are there, they will not be much efficient to attack on the electrophile, resulting no reaction with the Friedel-Crafts alkylation. Okay, the third one is, whenever it is aniline and pyridine are there, they act like a Lewis bases, so they will be going to form Lewis acid base complex with the Lewis acids that are present in the reaction, so resulting into the no reactions. Okay, So these are the exceptions. Okay. So one more example, which is appeared in the previous examination for the Friedel-Crafts calculation is based on naphthalene. When it is treated with methyl chloride in the presence of CS2, okay, carbon disulfide, which is a non-polar solvent. Okay, carbon disulfide, which is a non-polar solvent. So in presence of non-polar solvent, so methylation happens at alpha position. Okay, in presence of nitromethane solvent. Okay, nitromethane as a solvent. So it's going to give beta substitute. Okay, so these type of questions will be framed from the recent publications based on the reactivity types and the recent advances in the reactions. So that may be also asked in the JAM. Okay, so this is one of the JAM examination questions. Okay, so I'm trying to cover more and more previous questions. So hope you utilize them. Okay, and catch up them. So this is beta. So it is just a solvent effect. Okay, nothing else. So solvent is going to change the positions. Okay, so solvent effect. So next, Friedel-Crafts acylation. So alkylation means alkyl group. Okay, so acylation means it is RC double bond O addition. Okay, so acetylation means CH3C double bond O addition. Okay, so this is acyl group, this is acetyl group. Okay, so this is common name and this is specific to the two carbons here. Okay, so this is alkyl. If it is alkyl group is attached, it is alkylation. If it is acyl group attached, acetylation. If it is acyl group attached, acylation. Okay, so here also aromatic ring is going to taken. So in acylation, the product will be with acyl group. Okay, so what could be the reagent? So it is very simple. You add a halogen here and add a Lewis acid here. So this is what Friedel-Crafts acylation. Okay, so in presence of Lewis acid and acyl halides. Okay, acyl halides. So based on the change in the acyl group, the number of carbons also represent in the product. Okay, so one more reagent for so if I use acyl group, acyl halides, so it's going to give RC double bond O plus and AlCl4 minus. Okay, so acyl carbocation is the intermediate here. Okay, acyl carbocation. So how how can we make the acyl carbocation in another form is if I use acetic anhydride or acyl anhydride and if I treat with the AlCl3, okay, AlCl3, so this is going to attack, so this bond is going to move, so RC double bond O plus and RC double bond O AlCl3. So this is also going to give the acyl carbocation. Okay, so there are two different ways. Okay, we can also find the different ways. Okay, so this is what acyl anhydride, acyl anhydride. You can also use acetic anhydride, which is this. This is what acetic anhydride we generally represent as AC2O. Okay, so AC means this is what AC, acetyl group. Okay, AC means acetyl group. So AC2O means, so it is acetic anhydride. Okay, so let's see the different examples based on this Friedel-Crafts acylation. Okay, Here I am taking benzene and treat with CH3 C double bond O Cl in presence of AlCl3. So what could be the product? It will be acetyl benzene. Okay, that is what acetophenol. So for example, I am writing one. Okay, so reaction mechanism will be same as like the all electrophilic substitution reactions. No change in the reaction and mechanism. Only examples are very important. So try to work out more and more examples. So this is benzyl chloride. So what could be the product? So this is acetophenol. So if it is a benzyl chloride, it will be benzophenol. So try to draw the product and write the name. If it is acetic anhydride, it is also going to release acetyl carbocation. Okay, so resulting product will be acetophenol. So propanyl chloride, what could be the product? Okay, so is it going to give the major product as what we expected, or is it going to give the different product as like in Friedel-Crafts alkylation? So this is about the Friedel-Crafts acylation. Okay, so some more examples which are very important. So try to make the benzene into the N-propyl benzene. Okay, so in Friedel-Crafts acylation, we could not able to make N-propyl benzene, but through alkylation we could not able to make, but through acylation we can make. Try to work out that. Okay, so how to do that? This is biphenyl system. If it is benzene with malonic anhydride, sorry, this is succinic anhydride and AlCl3. What could be the product? Okay. And one more. So if I extend this, so H plus, it will be B. Okay, so B and reduction with zinc, Hg, HCl, it will be C. C, if it is treated with palladium bicarbonate, so it's going to give naphthalene. So this is what one of the important questions repeated in the many exams. So how to do that? Try to work out. Okay. Next, similar to that, nothing. This is anthracene. So similar reagents and product will be different as starting materials got differ. Okay. So one more internal Friedel-Crafts acylation. So these are the workouts. So try to do more workouts. So here I have many more examples also. So if you can work out this, they are sufficient for any examination. So take a look. Okay. So overall, what we discussed in electrophilic substitution reactions are, it is about the halogenation. Okay. So in halogenation, reagent was halogen with Lewis acid. Okay. So electrophile was halonium electrophile. Okay. And the product was halobenzene. Okay. So in the second, it was nitration. Reagent was nitration mixture HNO3 H2SO4, which are concentrated. Okay. So here I am just giving the table, okay, tabular form of all reactions which were studied in the electrophilic substitution reactions. Okay. So this may be useful for recap, easy recap. Okay. So if it is nitration, NO2 electrophile will be going to form. Okay. So resulting product is what? Nitrobenzene. Okay. Next, we have seen sulfonation and reagent will be sulfuric acid. So electrophile will be neutral. Okay. So this is a specialty. So resulting product will be sulfonic acid. Okay. Next, Gutterman coach. So when it is KO, it will be carbon monoxide with HCl. Okay. So in presence of Lewis acid. So resulting what? So formyl electrophile is formed. Okay. Formyl electrophile is formed. So product will be formylated benzene. Okay. Next, Gutterman aldehyde synthesis. So in this we have used HCl along with HCl in presence of Lewis acid ZnCl2. Here the electrophile will be iminium electrophile. Okay. So resulting product will be the formylated benzene. Okay, or benzaldehyde. Okay. Both the products are same, but reagent systems and electrophiles are different. Okay. Next, chloromethylation we have seen. So for chloromethylation we have used sorry, we have used formaldehyde along with the HCl. Okay. So carbocation will be hydroxy methyl carbocation is the intermediate. Okay. And resulting product will be chloromethyl benzene. Okay. Next, we've seen Friedel-Crafts alkylation. In this, we used alkyl halide in presence of the Lewis acid. So resulting electrophile will be alkyl electrophile. Okay, so methyl electrophile or methyl carbocation. The product will be alkylated benzene. Okay. Next, we have seen acylation. So acyl or acyl halide or acetic anhydride or acyl anhydride is used in presence of the Lewis acid. So acyl carbocation is the intermediate and product. Acylated benzene is the product. Okay. So this is about the electrophilic substitution reaction table. Okay. So here I covered almost all important reactions. Okay, and previous questions. So try to work out more. Okay. So if you are able to work out and if you are able to do or get the right products, so your marks with this topic, types of reaction marks or questions are going to be deal perfect in the examinations also. Okay, మీరు ఇక్కడ చేయగలిగితే ఎక్కడైనా చేయగలుగుతారు. సో డైలీ క్వశ్చన్స్ ప్రాక్టీస్ చేయండి అండ్ వాటిని కరెక్ట్ చేయడానికి ట్రై చేయండి. ఓకే, సో దట్స్ ఆల్. ఇఫ్ ఎనీ డౌట్స్ సెండ్ టు ది my mail, okay, which is described in